If you've ever looked up at the stars and wondered what it would take for humans to actually travel to them, you're not alone. Space exploration has always been a dream for many of us, but for most of history, it's felt out of reach. But what if I told you that in the year 2075 we've actually figured out how to send ships to the farthest reaches of the solar system, and beyond, using the light of the sun itself? Enter solar sails. Now I know what you're probably thinking. Solar sails? What, like a sailboat on water but in space? And kinda. It's an awesome idea that's been floating around for a while, but over the past few decades it's become a reality. In this video we're going to dive into the world of solar sails, which are transforming space travel as we know it. By 2075 they're not just a cool idea, they're the backbone of humanity's exploration of space. These sails harness the power of sunlight, turning it into thrust, and in doing so, they've completely changed the way we think about traveling through the cosmos. So, how did we go from a dream in the 20th century to a fleet of solar sail-powered ships cruising through space by 2075? Well, to understand that, we need to go back in time a little and take a look at what solar sails actually are, and how they're powered by the most abundant resource we have in space: sunlight. First things first, solar sails use light pressure. Think about it like this: light doesn't just illuminate things, it carries energy, even if you can't see it. Photons, which are the particles of light, have momentum, and when they hit something, they exert a tiny force. Now imagine a giant sail in space, just floating there. When photons from the sun hit it, they push it forward little by little, accelerating the spacecraft. It's a super subtle push, but over time, it builds up speed. And here's the really cool part. Unlike rockets, solar sails don't need fuel. There's no massive fuel tank burning up. The sun is an endless, renewable energy source. So as long as you've got sunlight, you've got power. It's like having a never-ending wind for a sailboat. But in this case, it's the vast emptiness of space and the never-ending supply of photons from the sun. Solar sails might sound like a futuristic concept, but they've actually been around for a while in theory. Scientists have been talking about it for decades. The first successful test of solar sails wasn't even in the 21st century. It dates back to the early 2000s with missions like Japan's Icaros, the first interplanetary spacecraft to successfully deploy a solar sail. It wasn't big, it wasn't fast, but it proved the concept worked. Fast forward a few decades, and in 2075, solar sails are now the backbone of deep space exploration. They've evolved from early experiments into highly efficient, massive sails, capable of carrying heavy loads, propelling cargo ships, and even carrying humans on long journeys beyond our wildest dreams. But before we get too far ahead of ourselves, let's look at the road that led us here. Because understanding the journey of solar sails, and the people behind them, helps us appreciate just how far we've come. Now, when we think about space exploration, we think about rockets, right? Those huge, thunderous launches that send astronauts and probes into space. But rockets have their limits. They rely on fuel that eventually runs out, and while they're great for getting to orbit or sending a probe to a nearby planet, they can't go on forever. So the idea of using sunlight to propel spacecraft was always in the back of researchers' minds. And over time, advancements in materials science, propulsion technology, and international collaboration made solar sails something that could actually work. Not just in theory, but in real life. In the next section we'll dive deeper into how solar sails work, how scientists figured out how to make them efficient enough for real missions, and how this technology has evolved. It's a fascinating journey from concept to reality, and you're going to want to stick around for it. Alright, so now that we have a basic idea of what solar sails are and how they work, let's take a closer look at the science behind them. Don't worry, I'll keep it simple and avoid getting too deep into the physics. But, trust me, this is pretty cool stuff. First, let's break down how solar sails actually work in space. You know how a sailboat catches wind on Earth, right? Well, solar sails do something similar, but instead of wind, they're catching sunlight. Sounds pretty basic, but the physics behind it is fascinating. Here's the key: light has energy, and that energy isn't just about shining brightly or warming up a surface. Light is made of particles called photons. Even though photons don't have mass, they do have momentum. And when these photons hit the sail, they transfer a tiny amount of their momentum to the sail. This gives the sail a small push, what we call light pressure. Now, you might be thinking, a tiny push? How is that even enough to move a spacecraft? It's all about the math. While the push from each photon is small, remember, light is constantly hitting the sail. And in space, there's no air resistance or friction to slow things down. So over time, that small, constant push can accelerate a spacecraft to incredible speeds. It's like a never-ending push that builds up momentum. In the vacuum of space, this adds up, especially with big, lightweight sails designed to catch as many photons as possible. But here's the thing. Solar sails work best in areas of space where there's plenty of sunlight. So they're most effective in the inner solar system, where sunlight is abundant. The further you go out, the weaker the sunlight gets, so the force generated by the sail decreases. That means solar sails are perfect for exploring nearby planets like Venus or Mars, and even getting out to the asteroid belt, but they get less effective as you travel farther out toward the outer planets. Let's talk materials. Early experiments with solar sails used lightweight, reflective materials like mylar and captain. These materials were great, but as solar sails became larger and more advanced, researchers needed materials that were not only light but also strong and durable enough to handle the harsh conditions of space. By the year 2075, scientists have developed a special kind of sail material, something like a super-thin, flexible alloy, mixed with advanced polymers, making it both lightweight and extremely resilient. This new material is able to withstand the rigors of space travel, from cosmic radiation to micrometeoroid impacts. One of the breakthroughs in solar sail technology came from refining the way we deploy and control these sails. In the beginning, it was tricky to get the sails to deploy properly in space. Early models used strings or mechanisms to unfold the sails once they were in orbit, but as sails got bigger and more complex, we needed more sophisticated solutions. This is where solar sail technology really shines. It's not just about having a big sail and hoping for the best. The precision of modern sails means they can be constantly adjusted and fine-tuned. And that's how spacecraft using solar sails can achieve sustained, efficient travel over long distances. But while the materials and technology have come a long way, the real magic happens when these sails are combined with mission planning. Solar sails allow for missions that were once unthinkable, sending probes out to the outer reaches of the solar system without relying on fuel or traditional propulsion systems. In fact, one of the biggest advantages of solar sails is their ability to travel for years, even decades, without needing to stop for refueling or maintenance. This makes them perfect for long-term exploration missions, like reaching distant asteroids, or even sending probes to the farthest corners of our solar system and beyond. The most exciting part of this technology is that it opens up space for missions that are far more cost-effective and sustainable than the traditional rocket-powered missions we're used to. And this is just the beginning. By 2075, we've already launched fleets of solar sail-powered spacecraft, with even more ambitious missions planned for the coming decades. But of course, with every new technology comes new challenges. As powerful as solar sails are, they still have limitations. They're not going to replace rockets for quick trips to the moon or heavy payloads. But for exploring distant worlds, solar sails offer a revolutionary, low-cost alternative. And this technology keeps evolving, faster, lighter, stronger, more precise, pushing us further into the unknown. Alright, with that in mind, let's take a look at how these advances in solar sail technology were tested and refined in the early 21st century. How did we go from the first solar sail experiments to the cutting-edge ships we see in 2075? That's where the real adventure begins. So let's rewind a bit. We've talked about how solar sails work and the science behind them. But how did we get from a cool idea to real missions actually using solar sails? Well, the road was a bit bumpy at first, but with each step, we got closer to making the dream of interplanetary and even interstellar travel a reality. Let's start with the very first successful solar sail mission, Icaros. This was a game changer. In 2010, Japan launched Icaros, the first spacecraft to use a solar sail for propulsion. It wasn't a massive mission by 2075 standards, but it was a huge milestone. The sail was only about 14 meters wide, which sounds pretty small, right? But back then, this was cutting-edge tech. Icaros proved that it was possible to deploy a sail in space and actually use sunlight to push a spacecraft forward. The mission wasn't about speed. It was about showing that this technology could work over time. And it did. Icaros not only showed that the concept was possible, but it also demonstrated how solar sails could be controlled and adjusted in the harsh environment of space. After Icaros, other countries and private organizations jumped on board. The next big mission was LightSail 1, a project from the Planetary Society. LightSail 1 launched in 2015, and while it was a smaller mission, it proved that solar sails could function in Earth orbit. The success of LightSail 1 helped drive more interest in the technology, and it led to the launch of even more advanced versions. By 2020, LightSail 2 was up and running. This one was able to successfully demonstrate solar sailing for longer periods, proving the viability of using solar sails to maneuver in orbit. But it wasn't just small-scale experiments. As technology advanced, the stakes got higher. Bigger and bolder missions started taking shape, with teams working to develop sails that could handle the vast distances between planets, and even potentially beyond our solar system. Now here's where things get really interesting. By the mid-2020s, we started to see the real potential of solar sails for missions beyond Earth's orbit. One of the key turning points came when NASA partnered with private companies and space agencies around the world to design a new generation of solar sail spacecraft. They wanted to use the sails not just to get around low Earth orbit, but to travel to the Moon, Mars, and even the outer planets. It was no longer just about small, experimental sails, it was about creating full-fledged spacecraft that could carry out real scientific missions. One of the first big missions that showcased solar sails for interplanetary travel was the Solar Probe mission to Venus. The idea was simple but ambitious. Use solar sails to send a probe to Venus, using the sun's energy to propel the spacecraft across millions of miles. This was no easy task, though. Venus is known for its thick atmosphere, high temperatures, and high radiation levels, so designing a sail that could survive in those conditions was a massive challenge. But by 2030, after years of development, the Solar Probe mission successfully launched. The probe sailed past Venus, collecting valuable data about the planet's atmosphere and surface, and it was all powered by the sun's light. This mission wasn't just about testing solar sails, it was about proving that we could use them for actual space science, opening up a whole new era for planetary exploration. By the 2040s, solar sails had started to become a common feature in many space missions. They were no longer just experimental tools, they were being used in all sorts of ways. The next big leap came when solar sails were used in the first mission to explore the asteroid belt. Imagine sending a spacecraft into the vast void of space, using nothing but sunlight to keep it moving. That's exactly what happened when a solar sail mission was launched to explore asteroids like Ceres and Vesta. Not only did these missions provide incredible data about the composition of asteroids, but they also showcased just how far solar sails could take us. At this point, solar sails were becoming a serious player in the world of space exploration. The fact that we were sending missions to distant places like Venus, the asteroid belt, and even planning for missions to Mars and Jupiter, meant that we were starting to realize the true potential of solar sails. They weren't just helping us explore our own solar system, they were also laying the groundwork for deep space exploration. And then around the mid-2050s, things got even more exciting. By this time, solar sails were being used in deep space missions that were pushing the boundaries of where we thought we could go. For example, one of the most exciting projects was the Voyager extension mission, which used solar sails to send a probe further out into the interstellar space beyond the influence of our sun. For the first time, humanity was sending a spacecraft out into the vastness of space, powered only by light from the stars. This wasn't just a test or a small project, it was a full-blown mission that set the stage for humanity's future in deep space. The early missions were the foundation, and each one brought its own challenges and triumphs. They showed that solar sails weren't just science fiction anymore. They were a functional, reliable technology that could take us places rockets never could. By the time we hit 2075, solar sails had already become the standard for long-duration space travel. It wasn't all smooth sailing, of course. There were setbacks and problems to solve along the way. There were times when sails wouldn't deploy properly, or when space debris would damage a sail, or when the spacecraft's trajectory had to be adjusted mid-flight. But these early missions taught us how to overcome those challenges, and how to make solar sails even better. They set the stage for the huge fleets of spacecraft we have today in 2075. Missions that are no longer just reaching for the stars but venturing beyond them. But here's where things really get exciting. By the 2060s and 2070s, solar sails were no longer just cool experiments. They were a full-fledged game-changer for space exploration, and humanity had built an entire fleet of solar sail-powered spacecraft. Now you might be wondering, what makes this fleet so special? Well, up until now, space travel had been largely dominated by traditional rockets. Rockets are great for getting things off Earth, but they come with major limitations. They're expensive, they're fuel-hungry, and after they launch, they can't keep going forever. Solar sails, on the other hand, don't have those issues. They don't need fuel to keep moving, they don't require constant maintenance, and as long as there's sunlight, they can keep accelerating. This means we could start launching far more ambitious missions without the need for expensive fuel and complicated technology. By the 2070s, solar sails were everywhere, and I mean everywhere. Missions to the Moon, Mars, and Jupiter, cargo ships heading to distant space stations, and even missions venturing into deep space, heading beyond our solar system. It was like a fleet of futuristic spaceships had just appeared overnight. It wasn't just NASA anymore. Private companies and international collaborations had really gotten into the solar sail game. The cost of building, launching, and operating these ships had dropped dramatically, making space travel more accessible than ever before. So how did we get here? How did solar sails go from small experiments to the backbone of our space fleet? Well, it came down to a few key advancements: better materials, improved technology, and collaboration on a global scale. First, let's talk about materials. Remember those early sails made of mylar and captain? By 2075, things had come a long way. These early materials were lightweight and effective, but they weren't exactly the most durable. Fast forward to the 2060s, and engineers developed a new material that's even lighter, stronger, and more heat-resistant than anything we'd seen before. This next-generation material is made from ultra-thin carbon-based composites, something called graphene, combined with advanced polymers. These new materials are not only more resilient to space radiation and micrometeoroids, but also much easier to deploy in space, meaning bigger sails could be used more efficiently. With this new material, solar sails could be built larger and more robust than ever before, allowing for more efficient propulsion and longer-lasting missions. And as the sails got bigger, the spacecraft they were attached to got more powerful. These ships could carry much larger payloads like scientific instruments, cargo, and even passengers. Plus, they could travel faster and farther. Next, we have the technology that made these sails so effective in 2075. One of the biggest breakthroughs came in sail deployment. In the early days, it was a bit like unfolding a giant parachute, hoping everything went smoothly. But by the 2060s, solar sails were equipped with smart technologies that allowed for precise control. The sails are made up of hundreds or even thousands of tiny individual panels, each one capable of adjusting its angle to maximize sunlight capture. This lets the spacecraft continually optimize its speed and trajectory while in flight, a huge leap forward in efficiency. Also, the systems on board these spacecraft became more autonomous. Solar sail ships are now equipped with AI-powered control systems that can adjust the sails in real time, calculate the optimal path, and even perform maintenance tasks without human intervention. This kind of autonomous tech means that solar sail missions can last much longer, without needing to constantly check in or rely on mission control. This has been especially important for missions in deep space, where communication delays are measured in hours or even days. Then, of course, there's the power of collaboration. As the potential of solar sails became clear, space agencies around the world began teaming up. Instead of working in isolation, we saw a new era of global cooperation. NASA, the European Space Agency, private companies like SpaceX, and even emerging space programs from countries like India and China began pooling resources to develop and launch these missions. With such a wide range of organizations working together, the cost of missions dropped significantly, and suddenly, space exploration became more of a shared global effort rather than something that only the largest powers could afford. One of the biggest moments of this cooperative revolution came in the late 2060s, when the first interplanetary trade route was established. Solar sail-powered cargo ships began regularly transporting goods between Earth, the Moon, Mars, and even the outer reaches of the solar system. These trade routes helped to stimulate the space economy, with solar sails facilitating everything from scientific missions to the transport of resources for future colonization efforts. And it wasn't just about cargo, solar sails enabled space tourism too. By the 2070s, people were taking vacations to space. Whether it was a leisurely trip to Mars or a cruise around the Moon, these solar sail ships made it possible. What used to be the stuff of science fiction became a booming industry, as travel to space became more affordable and accessible to the public. Imagine taking a luxury cruise through the asteroid belt powered entirely by sunlight. The most incredible part? These solar sail fleets were paving the way for humanity to not just stay in the solar system, but to explore the vast expanse of interstellar space. By 2075, we had launched several missions using solar sails that were already heading toward distant stars. While we're still a long way from achieving true interstellar travel, the very fact that we're launching spacecraft that could eventually leave our solar system is mind-blowing. In the next part, we'll explore how these solar sail missions are making their mark on space travel today, how they're pushing the boundaries of exploration and opening up new frontiers in ways we never thought possible. Now that we've seen how solar sails went from an experimental idea to a major player in space exploration, let's zoom in on what the solar sail fleet looks like in 2075. This is where the real magic happens. We're not just talking about a few small, lightweight missions anymore. By now, solar sails have become the go-to technology for long-range space travel, and they're pushing the boundaries of human exploration in ways we never thought possible. Imagine this. By 2075, we have a fleet of solar sail-powered ships out there, ranging from small probes to massive cargo vessels and even passenger ships. Some of these ships are traveling within our solar system, while others are pushing past the edges of our solar system, heading toward the stars. And all of this is happening because solar sails can harness the power of sunlight, constantly accelerating with no need for fuel. It's truly a space-age revolution. Let's start with the missions within our own solar system. The most notable change by 2075 is how much more efficient space travel has become. For example, ships traveling between Earth, Mars, and the Moon used to take months or even years, depending on the method of propulsion. But with solar sails, the same trip can be completed in a fraction of the time thanks to the constant thrust they provide. Solar sail-powered ships can accelerate steadily over long periods of time, so instead of relying on short, powerful bursts of fuel to get somewhere fast, they can travel smoothly and steadily across vast distances. This makes them perfect for all sorts of tasks. Everything from setting up colonies on Mars to sending probes to distant moons like Europa or Enceladus. Let's take a look at Mars for a moment. By 2075, we've established permanent bases there, and solar sails are absolutely key to keeping everything running. Not only are solar sails used to transport supplies from Earth, but they're also used to carry resources between the Moon and Mars. The cargo ships are massive, and some of them even carry large mining equipment to extract resources from Mars's surface. The energy efficiency of solar sails makes these missions sustainable. Instead of hauling fuel all the way to Mars, ships can rely on the sun's energy, which, in the long run, saves a huge amount of cost and resources. But the solar sail fleet isn't just limited to interplanetary travel. Some ships in the fleet are heading farther out, way farther out. We've now got probes heading toward the outer planets like Neptune and Uranus, which were once considered too distant to reach with traditional rockets. The solar sail-powered ships don't have to deal with the same fuel limitations, so they can travel to these faraway destinations without worrying about running out of fuel or losing speed. The most mind-blowing part? Some of these ships have been launched with one goal in mind: exploring the stars. Yes, you heard that right. Solar sail technology has made it possible for humanity to send probes into interstellar space, beyond the influence of our sun. While these ships aren't anywhere near the speed of light yet, they're traveling at speeds that were once unimaginable. Some of these missions are on their way to nearby star systems like Alpha Centauri, and they could take decades or even centuries to reach their destination. But thanks to the relentless push of solar sails, they are steadily getting closer to their targets every single day. Take the Star Voyager, for example. This ship was launched in the late 2060s and it's currently headed toward Proxima Centauri, the closest star to our sun. It's not a human-crewed mission, at least not yet, but it carries an array of scientific instruments that will eventually send back data about the star system, including the potential for habitable planets. Solar sails are the reason this mission is possible. Without them, we'd still be relying on rockets that would run out of fuel long before even getting close to another star. But the constant push of the sails means the Star Voyager can keep going, powered only by sunlight for decades to come. And while we're talking about distant stars, let's touch on something even more exciting. In 2075, we've got a fleet of deep space exploration ships, with crews aboard, that are already preparing to leave the solar system. These ships aren't just probes anymore, they're built for people. Imagine being one of the first humans to step aboard a spacecraft that's headed to a distant star, living out there in the vast nothingness, relying on solar sails to keep you going. These long-term missions to the stars are still in their early stages, but solar sails have made it possible to think about them seriously. These interstellar missions are still in the experimental phase, of course. We're not sending massive colonies or luxury liners to other stars just yet, but there are already plans in motion for the first human crews to venture beyond the solar system, and these crews will rely heavily on solar sails to get there. The journey will take decades, if not centuries, but the ships will keep accelerating, powered by sunlight. And let's not forget the growing role of solar sails in space tourism. By 2075, commercial space travel is no longer just a dream. Regular trips to the Moon, Mars, and even out to the asteroid belt are becoming more common. And while many space tourists still travel on conventional rocket-powered ships, a growing number of luxury space travel companies are offering voyages aboard solar sail-powered ships. These ships offer a smoother, more peaceful ride, no loud engines, no fiery launches, just the quiet hum of solar-powered propulsion as you drift through the cosmos. It's like taking a cruise through space, and these kinds of voyages are gaining popularity. As these solar sail ships get bigger, smarter, and more capable, they're opening up new opportunities for scientific research, economic growth, and even interplanetary commerce. From Mars colonies to the asteroid belt to the outer edges of the solar system, the fleet of solar sail ships in 2075 is pushing humanity further into space than we've ever been before. So now we know that by 2075, solar sail-powered ships are everywhere, from the Moon to Mars to the farthest reaches of our solar system. But what's it like on board these incredible spacecraft? What's life like for the people traveling on them, whether they're space tourists, scientists, or astronauts heading to distant stars? Well, let's take a peek inside these futuristic ships. First off, one of the most noticeable differences about life aboard a solar sail ship is the environment. You've got these massive sails catching the sunlight outside, but once you're inside, it's a totally different world. These ships are designed for long-term travel, which means they're built for comfort and practicality. Gone are the cramped, metallic, utilitarian designs of early spacecraft. By 2075, space travel is all about maximizing efficiency and livability, especially for these long-haul journeys. You might think of them as a combination of a luxury cruise ship and a high-tech space laboratory. The first thing you'll notice inside these ships is the space itself. They're often much bigger than you might expect. Solar sail ships can be enormous because they don't need the kind of heavy propulsion systems traditional spacecraft do. They have more room for human crews, research equipment, and even amenities that make life easier on long journeys. For crew members heading on a long mission, whether it's a scientific expedition to an outer planet or a deep space probe, these ships are equipped with everything needed to keep people healthy, comfortable, and productive. There are sleeping quarters, workstations, and even common areas to relax in, designed with the goal of making life in space feel more like a home away from home. You can expect advanced life support systems that recycle air and water, ensuring that astronauts and space tourists never run out of resources. These systems have come a long way from the old days when astronauts had to rely on limited supplies. Today there's nearly zero waste on board because everything, water, oxygen, even food, is constantly being recycled. And because these ships are self-sustaining, they don't have to rely on resupply missions from Earth, which is a game-changer for long-duration travel. Now let's talk about the solar sails themselves. These sails aren't just there for propulsion, they also help with power generation. The energy collected by the sails is distributed throughout the ship to keep everything running. That means the ships don't need large, bulky fuel reserves or external power sources to operate. The solar sails collect sunlight, even in deep space, where the intensity of the sun's light might be weaker. This steady power flow is what allows these ships to function over long periods of time. For missions heading beyond the solar system, this power generation is especially important. As we get farther from the sunlight becomes weaker, but it doesn't stop the sails from providing a continuous push. Ships heading into deep space rely on powerful onboard AI systems to manage power distribution, monitor ship systems, and even adjust the sails for optimal propulsion. These systems can track the best angle to catch sunlight at any moment, allowing the ship to maintain speed and direction without human input. And let's not forget about the crew. On missions that involve deep space exploration or interplanetary travel, you can expect a highly trained team of astronauts, scientists, and engineers. They live and work in the ship for months or years, depending on the mission. These crews are responsible for maintaining the ship's systems, conducting experiments, and keeping the crew safe and healthy. The longer the mission, the more important their role becomes in ensuring everything runs smoothly. But unlike past space missions where astronauts were isolated and cut off from Earth, the crews of solar sail ships can stay in regular communication with mission control and even with their families and friends through advanced communication networks. The technology on board allows for near-instant communication, so long-distance space travel doesn't feel as isolated as it once did. For tourists traveling on solar sail ships, it's a totally different experience. These ships are designed to make the journey an adventure in itself. Imagine floating peacefully through space with nothing but the stars outside your window. The ships are equipped with massive observation windows, where passengers can watch the cosmos unfold in front of them. The interior is far from sterile. Think luxury space cabins with comfortable seating, dining areas, and even virtual entertainment systems to keep everyone entertained as they cruise through the cosmos. And because these ships are powered by sunlight, the trips are quiet and smooth, with no loud engines or jarring acceleration. It's like being on a cruise but through the vastness of space. When it comes to food and dining, space tourism and deep space travel have come a long way. Gone are the days of freeze-dried meals. Today, food is grown on board in hydroponic farms or prepared in high-tech kitchens. Astronauts, scientists, and tourists all enjoy fresh, nutritious meals on these ships, made from crops grown in space. These onboard farms use a closed-loop system that recycles nutrients, water, and waste to ensure the freshest food possible. It's a sustainable and delicious way to keep everyone happy and healthy during long journeys. Of course, these ships aren't just about luxury. They're about ensuring that the crew can accomplish their mission. Whether it's exploring a distant planet or sending back data from a probe beyond the solar system, solar sail ships are fully equipped with research labs, observatories, and all the tools necessary for scientific discovery. The onboard labs are designed to function in microgravity, with state-of-the-art equipment that lets scientists analyze samples, run experiments, and monitor the ship's surroundings in ways that were never possible before. And there's something really special about working in space. Whether it's for astronauts or scientists, The experience of conducting research in zero gravity or exploring other planets is transformative. The ability to do hands-on research while cruising through space makes every day on a solar sail ship unique. Every mission is a chance to make new discoveries, and that's what keeps people excited even after months or years of travel. As these ships venture farther out, life on board becomes a whole new frontier of exploration. And it's not just about getting to new places. It's about the people who are experiencing these places in real time. Whether you're a scientist collecting data from distant asteroids or a space tourist watching the stars drift by, life aboard a solar sail ship in 2075 is all about pushing the boundaries of human exploration while making it feel like home. By 2075, solar sails have completely transformed how we explore space, but it hasn't all been smooth sailing. There are still plenty of challenges, both big and small, that come with relying on this innovative technology. These challenges are a reminder that, while solar sails are incredible, they're still pushing the limits of what we can achieve in space. So, let's take a look at some of the hurdles we've had to overcome, and some that we're still working through. One of the biggest challenges early on, and even today, is sail deployment. Back in the early days when we first started experimenting with solar sails, getting the sail to unfurl properly in the vacuum of space was a tricky process. If the sail didn't deploy correctly, the spacecraft could become useless, drifting aimlessly with no way to harness the sun's energy. Imagine trying to open a giant umbrella in space where there's no atmosphere to help guide it. Engineers had to design highly precise systems to ensure the sails unfurled correctly and were able to maintain their shape in the harsh environment of space. While the deployment systems have come a long way, they're not perfect yet. There are still occasional malfunctions. For instance, solar sail panels are delicate and can be damaged by things like micrometeoroids or debris from other spacecraft. Even tiny particles traveling at extremely high speeds can tear a sail or cause it to lose its shape. And when you're traveling deep into space, repairs are basically impossible. So the durability of sails remains a major concern, especially for long-duration missions. On top of that, there's the issue of space debris. Over the decades, the number of defunct satellites and small particles in space has skyrocketed. When you're relying on something as thin and fragile as a solar sail to propel your spacecraft, that debris can pose a serious threat. Engineers have developed new materials and technologies to make the sails tougher and more resistant to damage, but it's still an ongoing battle to keep the sails intact in such a hostile environment. Then there's the challenge of constant acceleration. While solar sails don't need fuel to keep moving, they rely on the continuous pressure of sunlight to accelerate. The problem is that as a spacecraft moves farther from the sun, the light it captures becomes weaker. The farther you go, the less push you get. For missions traveling within our solar system, this isn't too much of a problem. But for ships venturing into deep space, where the sun's light is faint and distant, maintaining enough speed to reach distant destinations becomes much trickier. To counter this, some advanced solar sail designs incorporate reflective surfaces to increase the amount of sunlight they capture, helping them maintain consistent acceleration even as they venture further out. Still, the farther the mission, the more complicated it gets. Another challenge lies in the navigation and control of these ships. Unlike traditional spacecraft, which rely on rockets or thrusters to adjust their course, solar sail-powered ships are constantly being pushed in the same direction by sunlight. This means that maneuvering the ship is a little more complicated. While small adjustments can be made by changing the angle of the sail, large course corrections require a more creative approach. In some cases, gravitational slingshots around planets or asteroids are used to alter the trajectory of the spacecraft. But this method depends on the precise alignment of planets, so it's not always reliable. For some missions, that's no big deal, but for deep space probes or interstellar missions, being able to adjust your course quickly and accurately is crucial. That's why engineers have been working on hybrid systems that can combine solar sails with small thrusters like ion engines. These systems can help with major course corrections without requiring large amounts of fuel, giving ships the flexibility they need for precise navigation. But that's still an ongoing area of development, figuring out how to strike the balance between solar sail propulsion and supplemental thrusters. And then there's the matter of communication. As we send these solar sail-powered ships farther into space, the distances between spacecraft and mission control increase, which means longer communication delays. A simple message from Earth can take hours or even days to reach a spacecraft, and vice versa. When dealing with deep space missions or interstellar probes, communication becomes even more challenging, and real-time decisions are almost impossible. To manage this, spacecraft rely on highly autonomous AI systems to make decisions and carry out tasks without needing constant input from Earth. These AI systems need to be incredibly reliable and intelligent, capable of handling a range of situations that might arise on long missions, especially when those missions are years or decades long. And of course, there's the huge issue of power. As solar sails venture farther away from the sun, there's less and less sunlight to collect. While the sails can keep pushing the spacecraft forward, they don't generate quite as much power as they did closer to Earth. This means that some of these deep space missions have to rely on backup power systems, like nuclear generators or advanced batteries, to keep the ship's systems running. Finding ways to power these ships efficiently, especially on missions that could last decades or more, is a constant challenge for engineers. Let's not forget the effects of prolonged space travel on the human body. For human-crewed missions, especially those heading to distant stars, there are concerns about the long-term effects of weightlessness on bones and muscles. While artificial gravity could be created in some larger spacecraft, it's not always practical, especially in smaller ships or those that are more focused on efficiency. On top of that, the lack of a protective atmosphere means astronauts are exposed to more radiation from space. Advances in shielding technology have made great strides, but this remains a significant concern for long-duration human missions. And then there's the issue of scaling up. As more and more solar sail ships are launched, the need for better infrastructure becomes apparent. We're talking about building large, efficient solar sail farms for deep space exploration, developing large-scale manufacturing techniques for constructing sails, and improving launch systems to carry these massive sails into space. It's not just about the technology anymore, it's about creating the infrastructure that supports it. Despite all these challenges, we're making incredible progress. The fact that we've already sent missions beyond our solar system and have begun regular travel to distant planets is nothing short of amazing. Each of these challenges is an opportunity to learn and improve, and the innovations we're seeing today will pave the way for even greater achievements in the future. By 2075, solar sails have already done so much to change the game for space exploration, but believe it or not, we're just getting started. The potential for what these sails can do, and how they can revolutionize the way we explore the universe, is still being realized. So, let's take a look at what the future holds for solar sails beyond the year 2075. First off, let's talk about the big picture. We've already sent ships to other planets and even beyond our solar system, but the long-term goal for solar sails is nothing short of interstellar travel. Imagine sending a crew of astronauts to another star system, or better yet, sending an entire colony ship. It might sound like science fiction, but solar sails are the perfect technology for this kind of journey. With the ability to keep accelerating without needing fuel, they could eventually get us to distant stars much faster than we ever thought possible. And the technology to achieve that kind of journey is already on the horizon. In fact, there are ongoing discussions about sending the first interstellar mission in the coming decades. The idea is to send a small, lightweight probe, maybe even powered by lasers instead of sunlight, towards the closest stars. The concept is similar to the Breakthrough Starshot project, which aims to send tiny solar sail-powered probes to the Alpha Centauri system, the nearest star system to Earth. These probes could travel at a fraction of the speed of light, and while it would take decades or even centuries to reach their destination, they would be the first step in interstellar exploration. But that's just the beginning. As solar sail technology advances, we might see much larger ships capable of carrying people, resources, and even entire habitats to other star systems. These ships would travel at a consistent pace, accelerating slowly but steadily over time. And because solar sails don't require fuel, the ships could be self-sustaining for incredibly long journeys, making deep space exploration a reality. There's another possibility that might sound even more mind-blowing: solar sails that are powered by something other than sunlight. We've been talking a lot about solar sails being powered by the sun, but what if we could harness energy from other sources, like lasers or even interstellar radiation? Some researchers are already looking into using high-powered lasers to propel solar sails, a technology that could revolutionize space travel. The idea is to beam laser light from Earth or orbiting stations to push a sail in space. This would allow us to achieve much higher speeds and even bypass the limitations of sunlight as we move farther from the sun. With laser-powered sails, we could be sending probes to other star systems in just a few decades. One of the next big steps for solar sails is to scale up the missions. The ships we have now are impressive, but what happens when we start designing ships that can carry thousands of tons of cargo or entire colonies to distant planets? To do that, we'll need to innovate even further. We're talking about larger sails, more advanced materials, and new propulsion methods to allow these massive ships to launch and travel long distances. Some scientists and engineers are already exploring the idea of combining solar sails with other forms of propulsion to create hybrid spacecraft. For example, combining solar sails with nuclear-powered engines could allow ships to reach distant planets in a fraction of the time it would take using only solar sails. Another exciting possibility in the future of solar sails is the concept of space-based infrastructure. Imagine a network of solar sail-powered ships traveling between Earth, the Moon, Mars, and the asteroid belt, delivering resources and people. This network could form the backbone of a true space economy, with colonies on different planets and moons, all connected by solar sail-powered cargo ships. With the ability to deliver supplies and resources efficiently, we could build massive space stations, mining operations, and even luxury hotels in space, all powered by solar sails. And then, there's the idea of colonizing other planets and moons. Solar sails are already essential for transporting goods and resources between Earth, the Moon, and Mars, but as we start to establish permanent settlements on Mars and beyond, solar sails could play a critical role in sustaining these colonies. They could bring in supplies, transport people, and even be used to launch new missions to explore the outer solar system. In fact, solar sail-powered ships might even be the key to sending the first humans to live on distant moons like Europa or Titan, where humans could set up research bases or even colonies, harnessing the resources of these moons to survive in space. Now, while all of this sounds incredible, we can't ignore the challenges that still lie ahead. As amazing as solar sails are, there are still technological hurdles to overcome. We're talking about improving the strength and durability of the sails, making sure they can withstand the harsh conditions of deep space. And of course, we need to continue developing better ways to control these ships, especially as they travel farther from the sun and rely on weaker sunlight. Autonomous AI systems will become even more important as we push further into space, and we'll need to make sure they're up to the task of keeping these ships on course, maintaining systems, and ensuring the safety of those on board. Also, as we build bigger, more complex ships, the need for better space-based infrastructure will become even more critical. Spaceports, repair stations, refueling depots, these will be essential for supporting long-term missions and deep space travel. There are already concepts in the works for massive space stations that can serve as hubs for spacecraft traveling through our solar system, and even to the stars. In short, the future of solar sails is as bright as the stars they aim to reach. With each passing year, we're getting closer to realizing the dream of interstellar travel and creating a spacefaring civilization. Solar sails have already proven that they can take us further than we ever thought possible, and the future holds even more possibilities. So who knows, maybe in just a few decades we'll be able to look up at the stars and know that humanity is already on its way to explore